Hi everyone, welcome back to the videos for calculus. So in this section we'll discuss elasticity of demand and what does it mean in calculus that we know. Well, the demand is said to be elastic if it reacts strongly to the increase in price. So it's very sensitive to changes. It's said sometimes that it might pertain to luxury items such as automobiles, home loans, or jewelry. And on the other hand, the demand is inelastic if it's something like essentials, like everyday items or gas, for example, so it may not be very sensitive to slight increases in price. So if we denote delta to be change from now on and Q to be quantity as a demand in terms of price P, then we know, I think we may jump just a little too much, that here's how we can derive an equation for elasticity. If we track the changes in demand, which is negative delta Q over Q, we know that the demand is going to be decreasing as price increases. This is the change in price. And we can actually do the derivation. We can flip the fractions, negative delta Q over Q times P over delta P. Now note that we can group the deltas together, the two that change. So we can switch the Q and the delta P. Or as we start talking about derivative, the delta will become negative dQ over dP, or the derivative of demand with respect to P, price, times P over Q. Okay, so the demand is inelastic if E is less than 1 or not very sensitive to price changes. It's elastic if E is greater than 1. And we have this unit elasticity, which we'll see on the graph, which is E equals to 1. So if we recall from earlier in the semester that revenue is price times quantity, then we can relate elasticity in the following way. That if, notice, the maximum revenue, right at the top right here, corresponds to unit elasticity, wherein the price is just right. So it's a Goldilocks principle. It's not too high or too low. And notice how to the left of here, E is less than 1. So this is where the demand is inelastic. Scroll down a little bit. And to the right, E is greater than 1 when it's elastic. So notice to the left, the revenue is still increasing. So you can still keep on increasing the price to increase your revenue. And over here, the revenue is decreasing. So you can actually, you may want to lower the price to increase the revenue. Okay? So we can have a couple of problems. We can find elasticity. So for given demand, let's say if it's 50 minus P over 4, then, the way we can calculate the elasticity, so here is the equation, negative dQ over dP times P over Q. So if we take the derivative, note how 50 went away, but we'll get negative 1 over 4. So negatives cancel many times. And notice that we have P divided by the actual equation, the Q. So actually, what happened here, so it's positive 1 times P, so it stayed as P, and 4 went in the denominator. And notice how we can distribute the 4, so it becomes 200 minus P. And then we can also use elasticity to solve for maximum revenue as opposed to taking derivative of the revenue. So E equals 1 when the revenue is maximum. So you can set the equation equals to 1. And you can solve by multiplying both sides by denominator. And notice how we'll get 2P equals to 200. P is equal to 100. So this is the price that maximizes revenue. And we can also solve for quantity. So once you find the price, you can plug in into Q and solve for quantity. So in this case, we got 25 items. Okay, we can also solve, so this is the second equation follows the same exact idea. Okay, so I'll just scroll down. Notice how you may have P squared, so you may have to take the square root to solve for P. Generally, it follows the same idea. Now, another situation where you can do is you can calculate elasticity and plug in certain price points. So we have this next situation where the quantity is 400 minus 0.2 P squared. Calculate the elasticity and then plug in certain P. For example, P equals $20. So note how we calculate it. So the derivative in this case would be negative 0.4 P. This should be a negative actually. So the negatives cancel, and so you'll get 0.4 p squared over 400 minus 0.2 p squared. If you plug in p equals 20, what I got was 0.5, so that's less than 1. So what does that mean? If you recall, the demand is inelastic and the revenue is still increasing as price increases. So the price is a little too low. You can still increase your revenue. What if price is $40? Well, if we plug it in, this is what I got. So be careful when you have the denominator to put that in parentheses if you're calculating it on your graphing calculator. I got 8, which is much stronger, all of a sudden, much larger than 1. Definitely, it's very elastic here. So maybe doubling the price may not be such a good strategy. So maybe increase it very little by little. And here's an interesting problem, elasticity of crude oil. If we have this equation that models the demand for crude oil in the United States in 2008, so notice how it's p to a very small decimal exponent. We can still calculate the elasticity. And so when we take the derivative, I got negative of the, so the derivative would be negative 0.06 times that 2 million. So I got negative 145,000.867.74 p to the, if you decrease it by 1, you get negative 1.06 times p divided by the equation. Now notice when I multiply by the p, the negative 1.06 is going to add to the 1 right here because it's p times the exponent 1. So it becomes negative 0.06 again. And now note, on top and denominator, you can cancel it, and then you can divide the constants. So I got 0.06, a constant. So what happens when elasticity is constant? Well, it's definitely less than 1. It's definitely very inelastic. And in fact, it's inelastic regardless of the change in price. We don't even have to plug in the 40. So that tells you something about the demand for gas. At least that's how the situation was in 2008. Maybe it changed a little since then. And that's it for this section.